All right, let's have a look at this week's lab. So it's Lab 7 TFT Touch. And it says, by the start of Lab 8, upload a picture of your TFT touch screen to D2L Assignments Lab 7, demo the working lab to your instructor. And so it should have ESET 260, your name, and thermistor temperature nicely formatted to one decimal place like last week. Use at least 2 different fonts and 2 different colors. Display the XY coordinates of any touch input in the upper right-hand corner. So here I have a place for the X and Y, and then I have a little dash and a little space. So when I put my finger on it, it'll say P for pressed, for instance, and then show X and Y. Add 2 buttons that light the green and red LEDs on the discovery board when pressed and not when they were released. And so if I hit the green, hopefully you'll see the green light up. And if I push red, you'll see red. The resistive touchscreen is not set up for a multi-touch. So, you'll turn one on or the other. You can have especially with capacitive touch screens, to be able to support multi-touch. The operating system, the StemWin libraries can support multi-touch, but we don't have it implemented with this screen. Now, I was mentioning the other day kind of the way the resistive touch screen works. Essentially, it's like you had 2 potentiometers and you're reading off the center wiper. And the touch screen consists of an overlay, and when you put your finger on it, it's going to make a connection to the bottom layer. And so essentially you have 3 volts and ground driven on one side, and then you read from the other side with an A to D hooked up, and you read the relative voltages, and then you turn that into X and Y. And in the config folder, there's a touchscreen.c file that basically goes through some of that. In the screen that you have has an XT2046 driver chip in behind to take a lot of that. It's talked to through SPI. It's hooked up on SPI2, and it does all of that configuration or all of that reading and gives you raw values back. You then have to take that and say, okay, from the raw values, what size of screen do I have? Because that same overlay or the XT2046 could have a larger overlay for a 7-inch screen, for instance. And then when you read the raw values back, you have to say, hey, this is however many pixels do I have in the X and Y directions divided by, what I'm reading to see where your values are. And so why I need to know that, for sometimes depending on the resistive touchscreen, at the top of the screen you could read a minimum voltage, and at the bottom of the screen read a maximum, and then left and right. But depending on how they put the touchscreens, sometimes the max might be at the top and the min at the bottom, or the max at the right and the min at the left, or the other way around. So there's what are you reading at top? What are you reading at bottom? What are you reading at left? And what are you reading at right? And you kind of have to look at that and then say, take the biggest sum, subtract the smallest, and then figure out where your buttons are. And what'll happen if you get that wrong is I might be pressing green and I'm not seeing anything. But if I'm a little above it or a little to the right, maybe it shows off. If the min and maxes are swapped, if I push over where my red button is, you might see the green one push down. And that's because the touch screen isn't jiving with what you're drawing. So there's 2 different things. It's how I draw the graphical image, and we started 0, 0 at the top corner, and how you're interpreting the X and Y's of the touch, okay? And so we'll have to look at that a little bit. In order then also to get it going, I've wanted to talk a little bit about putting the buttons down, as well as some of the other things. If I go over to the large document on StemWin, one of the things I wanted to look at, for instance, was if we look here, it says different examples on displaying text. And there's basic routines and setting the color. This is actually showing us how to do reverse images and all of this kind of thing. And that's over looking at if I look at our text API, there's displaying characters, displaying strings. You can display strings in certain rectangles that you've drawn, and going to certain UI positions, going to certain X and Y positions. There's also a whole area here on displaying values. And I can display decimal, display, where are we? Display floats. And it wants, if I go and look at one, it'll say, hey, how many character positions do you want? So there's all sorts of routines, display hex values, display binary, display value in binary format. So it gives you all sorts of different options for some of this stuff. One of the things it will give me here, if I can go, is let's have a look at animations, memory, different widgets. Let's have a look at some of the widgets. So one of the widgets, there's check boxes and drop down boxes and different ones like that. Now, if I look at my button widget, it shows all the different things that I can do with my button. And I'm going to just zoom over into looking at the button API. So this is in week 7 touch info. I just grabbed the button API off of that large document. And it says the table below lists the available MWin button related routines in alphabetical order. Now they kind of changed that. There was a button create and they say it's obsolete now. So what they want is this button create EX, which creates a button widget. So it's that one right there that I want to use. There's also different, if I want to, for instance, set the background color of the button. You can set the color for when the button's pressed as opposed to the button released. It's got some default values. There's also a button is pressed. And if I look at button is pressed, it's going to give me a 1 or a 0 back if the button's pressed or not pressed. So I can actually say if button is pressed, and it will tell me if I'm there. Yeah.
Is your mic working?
I hope it is. Oh, is it not? Microphone access. Testing 1, 2, 3. I think so.
Okay.
Let's see. Last time I forgot to turn it on. I have the whole thing recorded, no audio. It's like, But thanks for checking. That's because it's kind of weird. It's just showing it brown there. Okay, so there's all sorts of routines that we can call. Button create EX is what I want to use to start off with to make my button work. And so we can put it on the screen. Whether it responds to your touch is another thing. That's to do with our touch screen. Did I get the X and Y in the right place? And I'll show you kind of where some of that is. And in fact, what I like to do is display the raw values, and then you can move your finger or move a pointer over to the very left and the very right and actually see what your screen is as opposed to somebody else's. So you can fine tune it. And some screens will have a calibration mode, and they'll basically go through that in software saying hit the X, and then they're able to calculate that. So we can put different fonts on it. You can do different alignment on your buttons. And so if we look at, I just zoomed in on button create EX, okay? And it says creates a button widget of a specific size at a specific location. And it says there's something known as a button handle, and then you have button create EX, so it's going to return a button handle. And then I pass to the parameters, it says X0, Y0, so that's going to be across and down as far as where my button is. And then the size of the button. So some of these widgets want the beginning X and Y and then the ending X and Y, and they'll draw, let's say, a line from here to there. This is saying it wants an X and Y position on the top left-hand corner of it, and then how big is it, okay, for the button. And then, so that's the X size and the Y size. And then it says of type WMHWin H parent, and it says H parent, handle of the parent window. If 0, the button widget will be the child of the desktop. And so um, we want the buttons to be part of the parent desktop. So for now, you just go 0. There are options to be able to have multiple different screens. You might have something, but we're just going to say 0 in this case. And then it says win flags, and it says refer to WM create window, the window manager, and then I think we've got, did it tell me W? Oh yeah, so win flags, window create flags, typically WMCF show in order to make it visible immediately. I also have WMCF hide. So I could create a button but hide it unless you do something, and then I could make it appear so that you could click on it. And so, but by default, I'm drawing a button. I want to be able to show off the button. So this WMCF show is what you would use. And then it's got external flags not used yet. And the window ID of the widget is kind of, it needs to keep track of, for instance, if I have buttons, which button is which. And it does return back a handle, but it needs to know the ID. And basically, it's an enumerated type. And to know what is to be on there, you kind of almost have to use the IntelliSense to be able to figure it out. So I've given you an example. So for one, let's say this create button is giving me returning a button handle. Okay, creates it and it gives me a button handle. So here, up top, above main, I'm going to define button handle and I'm going to give it a name. And so it's H button, handle of button, and I said L for left. Could be G for green, could be R for red, just some sort of handle for the button. So whatever you put in there, it needs to be of type button handle. And when I call button create, it's going to return this handle. When I have things like text or is the button pushed, I'm going to ask it, it wants the handle. So in this case, it would be H button L is what I would give it. Okay. So if I said, can't remember what the one was, if button pressed, H button L, then it will look at that button and tell me whether my finger is in the position of XY or X plus 30 or Y plus 60 to tell if it's in that square. And if it is, what will happen is it will actually look like the button is pressed and give you the default pressed colors, but then I'll get back a 1 or a 0 to see that the button was pressed. So this is kind of taking that information above and saying, okay, I have a button starting in the upper left corner, 10 over, 50 down. It is 30 wide, 60 long. And 0 was saying, hey, by default, if you want it the parent be 0, I want it to show it off automatically. These are other options for future use, which is again 0. And then it says GUI ID button 0. Okay, if you go type in GUI ID control space on IntelliSense, it'll say buttons and all sorts of other widgets. And by default, I think it has 9 buttons that it has there. You can also make up your own, but it wants a unique kind of number. And when you call button create X, that's the only time it uses that. Then all your other functions are going to refer to this button handle, okay, when I go and use it. And so that's kind of what you do to put a button together. Define a button handle. So if I had another one, I'd make another button handle and I'd call it H button R or H button, what have you. I would create a button wherever I wanted in the X and Y position, however big I want it to get it on the screen. Okay, and so if I put those in the right place, I can keep compiling them and creating them, and with WF show, and you should be able to adjust your buttons so that they're kind of on either side. When I look up here at this position for my X and Y coordinates, those are, well, we just looked at, you can display string, you can display hex values, you can display just decimal. If you go, like for instance, GUI display decimal, you just tell it how many digits your number is going to take. One of the options when you go look in the StemWin is it's going to show you how many decimal. Let me, where is it? Display values, GUI display decimal at. That's not a bad one. Okay, and so it says, hey, here's GUI display decimal. There's your value, your X and your Y, and then your length. Okay, so it needs to know how many characters it's going to take up. So you could display a decimal somewhere. You can also printf and print out just a string. I mean, some of you have done that already in various parts of it as well. Okay. So some of the other things to look at, where did we have it? Button is pressed. That's a handy one to look at. Returns back a 1 or a 0. There's a button set text, for instance, that's going to set the different text on the buttons. Okay. So we created the buttons, and that's kind of above our while one. You only need to create the button once. It doesn't need to be redrawn. It's going to exist there in my main loop. I'm going to check to see if the button was pressed. And so I just keep looking at the if button is pressed, pass it H button L or H button R or whatever you have, and do something. And what I want to do there is turn on a light, turn on the red light or the green light, depending on which button was pressed. And if your button isn't pressed, then turn them off. So that's in your else clause. In main.c, put the following in the user code begin private variable section. So up at the top, I need you to have an external GUI PID state. So it's a pressed state. And so that's at the top in your above your main.c. And then in the while one loop, just at the top of while one, GUI touch get state at the address of p state, and it gets the touch position of your pixels. And so then we run GUI touch exec, and it needs to be called each time to get a new touch screen input. So this updates and gets you the latest values, and then this runs through and updates the input. And it's required that this function is called at least 100 times a second. So what'll happen is it'll get really laggy and unresponsive if, for instance, you're toggling your light and doing a delay 500, because that won't let us do that 100 times a second. So you want to be able to move your finger across the screen and see it updating more real time. If it's able to read that, about 100 times a second is going to give that to you. And so if you are toggling your light at the half-second rate, you need to do something like do it through a flag and through an interrupt, okay? Because delay will no longer work nicely for you. Nope, not that one. Oh, don't have it open. That, by the way, is in the background there is Visual Studio Code working with Platform IO using the different libraries available. You can, for instance, run code using Arduino interface using STM32CubeMX, using mbed. You can use all those different development environments in the same kind of IDE, and gives you options. So let me just see where we are here. No, actually, on that, I was programming. Oh, let me. This here is for the TFT with the ILI 9341. I wanted to show you actually some samples of it. So let me just. So I wanted to show you the what's available. No, it's this one. So some of the, like the board we're using is called an STM32F407 board, but you can use a lot smaller. For instance, this little board here is called, on the internet, is called a blue pill board. It's an ST103. It's $2.87 for that board out of China. And so we're running 186 megahertz. We have 1 mega flash. This guy's got 128K of flash, is running at 72 megahertz. It's $2.87 Canadian. And this is what it does with that code there with the example libraries. That's using, I think the guy's name is Bodmer, his graphics library. And so I just grabbed this graphics library, hooked up a humidity sensor and temperature sensor on there, but that's just one of the sample code running in a relatively low end processor. And so, and then I've got a couple of pots hooked up there, and we'll see some of the little graphs going and things. I'll have those in the lab so you can see. But this screen is, what, $7 or something like that out of China. This board's, $287, so $10. You're reading up to, this can actually this has two A to Ds on it, but each one can read up to 16 channels, more than enough power to be able to do all sorts of fancy things with it. This is running about 4% or something of the flash memory, like almost nothing, kind of thing on there. So I wanted to show you that so that's known as a blue pill board. They're, like I say, about $3. There's also what's known as a black pill board, which is the 4 series, 401 and 411, which is closer to the chip that you're using. And same form factor, so it doesn't have all the I/O there. They're about $7. Okay, so doesn't take much to be able to put one of those together. So I wanted to show you just some of the other little boards that are around. That's a Nucleo board, which is again, this thing's about $13 in a pack, but it's like an Arduino Nano. And again, you can program it. I programmed this one in Arduino language, but using the Visual Studio Code and the Platform IO development environment, because it gives you the full debugging features. So I can single step through the code and things that you don't get in the Arduino Sketch kind of library. So there's those ones. If you want larger screens, they have the boards with larger screens, and that it typically uses ST's touch graphics interface, which is a drag and drop kind of interface for building up different graphical interfaces as well. So you can use those kind of boards as well. And so that's also an F7, about twice as powerful as your F4 as far as the boards go. The one that you have in Wayne's is an F7. So it's kind of in that kind of power category. As far as this is a kind of an interesting little board. It's got an ARM on board, but it's also got an FPGA on board. It's by a company, Cypress. It's called a PSOC. So it's got software programmable analog as well as digital. And so you can in one line of code, configure analog blocks to make a low pass filter, and then in another line of code, unload that and say, now it's, let's say, a bandpass filter or some other thing in the analog section. And you also have some FPGA digital, so you could make, say you wanted some shift registers in gates or something, you can do that kind of thing. PSOC has been around a long time. They do those kind of things. Again, that's kind of like a little $10 board. As far as, again, in the ARM kind, in the ST category, these are Nucleo boards. They're in the $12, $15 kind of range. The interesting thing about the Nucleo board is they have Arduino connectors for putting in any Arduino shields. They also have, these are called Morpho connectors, give them more I/O. Notice that we have it kind of routed out on the board because that's your ST-Link. When you put it in a project, you snap the ST-Link off, and now you can use that as a standalone programmer, and that can be not taking up power in your project. Okay, that's a Nucleo board. They have all sorts of ones across the families from F1s or F0s all the way up to F7s in that kind of format of board. So those are really kind of nice to have as well. I don't have a teensy. I do have a teensy, but I don't have a teensy in here. I have something that's teeny. This is a Max 326525 Pico. That's that little chip right in there. That's a 32-bit ARM. And there it's on a little breakout board to get a little bigger programming and things. So in these guys, you're running 96 megahertz, half a mega flash, 160K of RAM, one wire SPI, all in tiny, tiny boards. Okay, so that's what I have on one of those. So it's not just STs that you can look at. And ST has a little 8-pin job that you can use as well. Just a little 8-pin 32-bit microcontroller that's available. A couple more I'll show you. A few more I'll show you. And they've gone, depending on the board, you've got everything from, they have micro connectors, mini connectors, USB-C connectors. So I like this. This is called a 429, and it's basically got the screen you have on the board all at once. Let me see if I can do it. And if you're playing Pac-Man, so but it's the board you have with the screen you have all integrated into one kind of unit there. That's called a 429. Anybody remember the LCDs, what the name of them that you used in the Arduino class? What's the name of your LCD? Or what was the chip driver on it? 1602. Okay. It's also known as, that's a common one from Sharp. It's a 44780 or a 1602. It's the same chip underneath. But it also comes available, those are vacuum fluorescent displays. And so same controller that you're familiar with using, except just kind of a different layout if you want, a different look. So vacuum fluorescent displays. So you can get that kind of almost retro look or arcade kind of look or something if you want it. So you don't always have to go like with a TFT or something like that, or just have the 2-line by 16 something. Couple other ones. This is an ARM chip. That there is called a Arduino Nano board, a BLE board, and so it's 64 megahertz, Bluetooth 5, 1 mega flash, and so accelerometer and things on it. So it's a little board that has all sorts of that kind of stuff in it. They're probably more like 30, 40 bucks though, as opposed to some of these other ones. One of the last ones we'll have a look at, this one. Okay, and so this one is this is the same screen, the same TFT screen that you have, but because it's plugged into an Arduino, if you buy them out of China for the Arduino, they know that the Arduino has A to Ds on it, so they save money on the XT2046 to read the touchscreen interface. And so what they did instead was they just hooked them to where your A to D pins are, and they're expecting that your software says 3 volts and ground, read the A to D, 3 volts and ground, read the A to D, and get your XY values. Okay, there's not the separate chip on board to do it, but it's pinned out to just plug in, which is kind of nice. Okay, so that has the ability, and then what you should see on yours, if you touch the button, it's going to count up, and it shows me the position whenever you see it, whenever it prints out there. Okay, so one of the things we used last year, actually, this is called an IoT discovery board. That's a Wi-Fi module with an ARM chip on board. That's a 900 megahertz radio. That's Bluetooth with an ARM chip on board. That's your ST link with an ARM chip. That's the ARM there. And then it has accelerometer, gyro, the laser that I think Wayne has a little laser module for you in one of the things. That's the little laser distance sensor. It's kind of like the ultrasonic sensor you used in the Arduino course. So, it's one of the things I didn't like about this board is they do hook up a lot of stuff, but they don't pin out any of the I/O. So if you just want switches on it, it's a little bit of you can hook through the shield, but not if you got an LCD hooked up. Anyway, so that's one of the IoT discovery boards. All right. So this is just showing you the PIO interface. This is Visual Studio Code with Platform IO. And so it lets you make projects. But one of the things it does is it says, okay, if you want to do a new project, for instance, you can look at what board you want. For instance, I know I have a discovery board, or I know I have from all sorts of different manufacturers. And then if I am actually in a project, let me just go over to, let me go back over there. And that will go into, if I have a project and it has different libraries, for instance, it gives you the option of bringing these things in for all sorts of different development environments, and it'll bring it into this one interface. For instance, if I search ILI 9341, so that's the library I used there, which had that interface I just showed you. But there, it says up here Arduino. So it's expecting that I make a project, and when I go make project, it says, do you want Arduino, STM32Cube, embed, what environment do you want to run? This says, if you're in the Arduino environment, you can bring in the library for this. Some will say embed, some will say STM32Cube. And so you find a library that's compatible with the development setup that you're going to use, and you can bring it in and write the code in here. Okay, so that's Visual Studio Code and Platform IO. So it just gives you other options there. Okay. I want to just, where is it here? There we go. Come on. It's a little to respond here. there's a couple of things way down at the bottom here. Actually, on this, I commented a bunch out. Um, there is this thing, and we have uh, pen point X is GUI touch measure X, and then there is a pen point X0 is pen point dot X left minus X divisor pen point state X equals pen point X0. And then we have this. So this P state, it can either be the raw values or it can be the scale values on your screen. So in other words, you can read, I think on a lot of these screens, for instance, where is my, I have to find. So on the screen I have, when I put my finger all the way over to the left in raw value, just reading the values off the A to D, I get 137 to 1909. I get 161 to 1850. If I just left those values and I said, is the button pushed? It's going to want to see that my screen is 320 by 240. So if I read 1850, it has no idea. You won't ever register that. So you have to take whatever your touch input is and turn it into 0 to 319, 0 to 239. Okay. And so the whole point of some of these divisors is saying, okay, if I read 1850, how do I make that 320? When I read over to, what was it, 161, how do I make that 0? Because I want to read from 0, to, let's say, top and bottom 0 to 239. So how do I make that do that? So you need to divide it by what you read, by your 240 or by your 320, to get how many you need to move over for each pixel. If you do that right, then when I touch the buttons, it registers, oh, that's in my place. You're at whatever position I placed it at, and then the button will act like it's pressed. If it doesn't, it's because this stuff isn't matching up. So down here, I've just gone, okay, bottom minus top divided by 240, or right minus left divided by 320 gives me a divisor. And then I call that here, pen point X0. So P state, if it's pen point X0, will give me the scale values. If I do pen point X, it gives me the raw values. So I can say, because my screen, I read 169, you might read 180. It's a resistive touchscreen. Who knows how they put it on? Not only that, sometimes the touch screen is put like this, and sometimes it's put like this. So is the top the lower number? Is the bottom the lower number? And you have to massage that to give you the 0 to 319, 0 to the 239. Okay, that's all in touchscreen.c. Okay, and so if you, in your main routine, if you print it out, I wonder if I've got it there. Oh, I didn't put it in this one. So in your main while one loop, if you do a GUI display string, GUI display decimal at a certain place, I put it in the top right hand corner, display the raw values, see that it's where you're thinking they should be, display the massaged values, so it's reading between 0 and 319, then when your finger is over the button, it should turn color, and then it should respond to your positioning. Okay. Any questions? Hopefully that's enough to be able to figure it out.